Hi, welcome to Chem 106, Monday, May 18th. I hope you had a wonderful St. Patrick's Day. I made green muffins for St. Patrick's Day. They had spinach in them, oatmeal in them, maple syrup, and chocolate chips. So they're nutritious and delicious. And green. So Luke said you could taste the spinach in them. I don't taste the spinach in them, and my husband refuses to eat them. So, all right, we're gonna do number 59 together since everybody had some trouble with it. So this is going off of our notes that we took last week. This is a problem just like what we did in our examples. So what we have is we have ammonium chloride. And if you look at ammonium chloride, the first thing that should pop into your head is ammonium chloride is a ionic compound. So we're going to dissociate that ionic compound into its ions, and then we're going to think about which ion is going to cause a change in pH. Do you remember how we gave you those rules on which ion is going to change the pH? And if you remember, if you don't know the rules, what else could you do? You could look up the what? The Kas and the Kbs. Do you know off the top of your head which one's going to affect the pH? If you go back in your notes, you could look. And that's the one we're going to use for our reaction. Okay? This is why we spent so much time on this last week, is because this right here is the heart of these problems, and the reason why they're difficult is because you have to know, they're not just giving you it and you're plugging and chugging. You have to really use your chemistry. So it's an opportunity to really apply what you know. So we should have a rule about ammonium. And it should be, does ammonium change our pH or not? Does chloride change our pH or not? We had our rules on direction. It was about anions and cations. So go back and find those notes and see which anions and which cations change your pH. It was also in the section was titled Acid-Base Properties of Salts. If you remember, this one's neutral. I'll give you a hint. If this one's neutral, that means automatically what? This one is going to affect our pH. So let's go with it, shall we? You don't have a rule about what? Ammonium. You're right, ammonium isn't in one of the rules. So what you have to do is you have to look up what's next to it, and this is in your rules. Did you see that chloride is in your rules? No. Chloride, bromide, iodide, nitrate, and perchlorate are all neutral. We wrote that down last week. Do you want me to write it again? Yeah. These are neutral anions. Oops. None of these anions change the pH. So you have to know that. So this one is going to change the pH. So what do you think it's going to do? It has 4 H's around that nitrogen. What do you think it's going to do? Do you think it's going to take a hydrogen or give a hydrogen to that water that it's going to react with? Isidro, what do you think?
What do you give?
It is going to give, yes. So that's going to make our water hydronium. And then our leftovers is going to be this. So acids make what? Conjugate bases. And bases make conjugate acids. Always. How do you feel about that? So do you see how we got to our equation? Now we can fill in what we have. And in the problem, we have 0.2 molar of this. So that is our initial concentration. And this is a weak acid, right? So what do I instantly do if I have a weak anything?
ICE.
Yes, I do my ICE equation. Oops. I miswrote here. How do we feel about this? Now, what's our next step when we do this? Yeah, good job. Let's do that then. Now, I don't know my Ka for ammonium. What am I going to have to do? I'm going to have to go to my chart and look that up, right? So ammonium is pretty weak. I'm going to do all my favorite algebra. And I solve for x. I'm not using sig figs. Hopefully you can forgive me. And then I take this up and put that right there. And our job is to find the hydronium concentration. We just did. And then to find the pH, we're going to take the negative log of that. And what do you get? And that's how you do every single one of those problems in that section. Okay? So the first thing you need to do is dissociate your salt. Figure out which one's going to change your pH. The one that changes your pH is the equation that you're going to write out. Okay? And then you plug and chug after that. How does that make you feel? You can. All right. Now let's change gears. we are going to take some notes on polyprotic ions, or polyprotic acids. So polyprotic, we've talked a little bit about this. We're going to review it. This is in section 16-8 in your textbook. So if you turn to page 615 in your textbook, you can look at some awesome pictures. So the word poly, or I should say the prefix poly means many, and protic means protons. So that means that these have more than one proton. For example, that right there. If this is an acid and our water is a base, let's go through and do the acid thing. Alright, but notice I still have, so this would have a Ka, I still have another hydrogen to give away. And this would have a Ka. So let's look up those Kas and see what they are. So the Ka for H2S is 1 times 10 to the negative 7. The Ka for HS is 1 times 10 to the negative 19. So what do these numbers over here tell you about how often these are going to happen? What does this size right here compared to this size tell you about these? The top one's going to happen a lot more often. This one right here, negative 19, not going to happen very often. Do you remember our water? Water was 1 times 10 to the negative 14. Do you remember how often that one happens? If you had did we say a billion or a trillion? If you had a billion or a trillion water molecules, we had a billion? A billion water molecules, we calculated that you would only have one out of a billion that would do it, would fall apart. So this one right here isn't going to do this very often. You're going to need to like push it that way. Okay? However, can it happen? Yeah. So we need to think about it. So first thing you need to think about is what is a polyprotic? It's something that has more than one H to give away. The second thing you need to understand is every time it gives away a hydrogen, it's going to have a Ka. And usually the Kas get smaller and smaller and smaller every time. So if we turn the page and we see what they're talking about, on page 16, there they did the example calculating the pH of a solution of a polyprotic base. So there you have to go through two ICE equations. Okay? So do you want to try one of these? Okay, that sounds good. Let's do the check your understanding on page 617. So it says, what is the pH of a 0.1 molar oxalic acid solution. And they want us to look up the Ka's for our problem. An oxalic acid is H2C2O4. Do you remember what oxalic acid is in? It's in rhubarb. It's what makes rhubarb poisonous. You're never supposed to eat the leaf or the root of rhubarb, and that's what's in it that makes it poisonous. Okay, so if this is an acid, that means this is a base, and that means that it's going to give away one of the hydrogens to the water. So this is a neutral compound. If I take, and each hydrogen has a 1 plus, and I have 2 of them. If I take away a 1 plus from this neutral compound, it's not neutral anymore. So it picks up a charge. So now I have an ion. So what's my Ka for that? For oxalic acid. H2C2O4. Chemists love oxalic acid. Did we find the base? It would be oxalate. Alright, we're going to have to look that up. It's 5.4 times 10 to the negative 2. How are we feeling about this? Good? Okay, so we found the answer here and one answer here, but the third answer is we need to do more math for. We got to do our second set. Do you have a question? First of all, do you agree with my numbers?
Correct.
Would you get for X?
I got one positive, one negative, but the positive one is different, and my negative one is the same as yours.
Okay. Let me show you. I have this right here.
Yeah, mine's flipped for some reason.
Did you put a negative in front of C?
Yeah.
Okay. I'll redo it.
Oh wait. No, I didn't put. I put a negative instead of positive for 5.4. So never mind. I got it now.
Did you get my number?
Yep.
Okay. All right. Great question. So here's our concentration of hydronium. I can use that to find my pH. Here's my concentration of HC2O4 1-, but we also need C2O4 2-. Do you see how we need that in the problem? Now this is going to react with the water. This is an acid, this is a base. This is a H, not an Al. Now, this is different. I have to use my number here as the beginning of this problem. So that's the twist on these. So if you look this one up, it's 6.4 times 10 to the negative 5. Oops. Shoot.
I got x equals 0.0017.
I agree. And that goes right there. And that's your final answer. So do you see how to do those? So your homework, I put in Schoology. Your homework is 67 through 70.
So like on a test, they just ask what was the question.
If you want, I could find one for you, and that's what we can start class with tomorrow. Sound good?
Yep.
Okay.
So, do we start our homework?
Yep, you can start your homework.